we want to find the area in the interior of the polar graph. R squared is equal to 4 cosine 2 theta. So we need to graph this first to be able to determine our alpha and beta, or the limits of the integral. So because this is in terms of cosine, then we know that the graph will be symmetric with respect to the polar axis. So if this is my polar axis, all I need to do is graph the curve on the first quadrant and then see its copy its reflection over the fourth quadrant and so on. We recall that this is a lemniscate, and the graph of a lemniscate is like a propeller or a ribbon. Okay, so there you go. So let's find our values for R given some values of theta. We begin at 0, that's the point right here. At 0, 2 times 0 is 0, cosine 0 is 1, 1 times 4 is 4. Well, the square root of 4 is plus or minus 2. So when R is 0, when theta is 0, the value of R is 2. That's the positive side, and the negative side would be here. Okay, what about when theta is pi over 6? So pi over 6 is somewhere here. Okay. At pi over 6, then 2 times pi over 6 will become pi over 3. Cosine pi over 3 is 1/2. 1/2 times 4 is 2. Therefore, R is plus or minus square root of 2. And square root of 2 is about plus or minus 1.4. So our graph will be here. This is 1, this is 2, so somewhere here. The negative 1.4 will be in the extension, so somewhere here. Okay, what about at pi over 4? Pi over 4 times 2 is pi over 2. Cosine pi over 2 is 0. 0 times 4 is 0. The square root of 0 is 0. So at pi over 4, the value of R is at 0. And so we can see that the graph goes this way. If we just complete it with respect to the showing symmetry with respect to the polar axis, then we have the graph that we want. Now, we want to get the area of the region inside. This is the interior, okay? So because of symmetry, what we will do is simply get the area of 1/4 of the region and multiply the whole thing by 4. So using now our formula, A is equal to, let me multiply that by 4, times 1/2. Well, my limits now will be starting from 0 to pi over 2. I'm sorry, pi over 4. And R squared is 4 cosine theta. I don't have to square that because it's already squared, so let me copy it. D theta. We can pull out that 4. So 4 times 1/2 is 2. 2 times 4 is 8. Cosine 2 theta d theta. We will use U substitution here. Let U be equal to 2 theta. Du is equal to 2 d theta. So d theta is du over 2. So this becomes 8 cosine u, and d theta is du over 2. We can pull out that 1/2, and so this becomes 4. And the integral of cosine u is sine u. Now we can rewrite u in terms of 2 theta so that we can apply back the limits from 0 to pi over 4. So here we go. At pi over 4 minus sine of 2 times 0, well, this will give me pi over 2, and this will give me 0. Sine pi over 2 is 1. 1 times 4 is 4. So the area of the region inside the lemniscate is 4 units.